our lecture number 25. In this lecture, we will be going through a very precise two of the topic, nuclear reactions, fission and fusion, plus we will go through the nuclear reactor topic, right? So let's finish it. The first is nuclear fission, right? When you say nuclear fission, as the name is saying, fission, it's splitting off bigger nucleus into small nuclei, right? Like what happened? We can split a big nucleus into its sister components, right? I mean, its daughter components or whatever you want to say that. So that is how the things will be. So basically, in this case, the energy that is actually being broken up into is a uranium-235, which is a nuclear product, or you can say when you actually broken down it into, I mean, it's be broken, you will get a fission reaction, right? Now, fission reaction is basically can be undergone, or you can say induced fission, which means nuclear does not often split up on its own, right? And one is nuclear fission. So remember that we are not talking about the induced one, like the one which is automatically in. We are talking about the one in which you are bombarded it with the neutron, and you will get some of the byproducts along with that energy and further 3 neutrons. We will talk about this in a minute. Remember that it's a spontaneous sudden reaction. In this reaction, what exactly is happening? A nucleus is absorbed by the neutron, a particular nucleus, in that case, it's a uranium. It is absorbed that neutron into and becomes unstable, 92 236 uranium. And then that neutron is causing that uranium to broken down into barium and krypton. Along with that, there will be 3 further neutrons which are evolved, and lots of energy in the form of gamma rays are emitted out. It's an exothermic reaction. It means the input side, you have to provide less amount of energy, but as an output, you will get too much amount of energy in this. Now, if you check this out, these 3 neutrons, that is very important. These 3 neutrons are basically used, or these 0 neutrons can be there to actually perform a chain reaction, because these 3 neutron goes into further 3 atoms, and each neutron again release 3 further neutrons. So this reaction will go on and on and on and on until all the material, all the uranium will be finished. That's why we call this nuclear fission reaction as a nuclear fission chain reaction. This is a chain reaction. And it is exothermic because output energy is quite bigger than the input energy, right? The equation for that energy is this. 1 neutron bombarded with uranium 92 235 gives you krypton 3689, barium 56 144, along with the 3 neutrons and lots of energy. If you check it out on the left and the right, number of protons or proton number and nucleon number are same, right? This is what we called as a fission reaction. Then we have the product. The fission reaction have kinetic energy. So neutron and 2 small nuclei released in the fission reaction are highly radioactive and will have kinetic energy. The kinetic energy allows the fission product to move away from the original reaction site. So gamma rays carries excess amount of energy. This is one of the products. And neutron can start a chain reaction. So we do have neutrons that can start a chain reaction. Now, this is very interesting. This is an exothermic reaction now, okay? Now, next reaction is nuclear fusion. As the name suggests, fuse, it's fusing. And for that reaction, remember that you need a very high pressure and very much high temperature required. This reaction is not possible on this earth. For this reaction, we need to actually go on the sun to perform that, right? So this reaction can only be done in, you can say that reaction can only be performed in basically sun, that can be performed on the sun. So basically, now important few things. What is in this reaction? In this case, two hydrogen nuclei or two hydrogen nucleus jolt together and form a single nucleus. So in this case, the important part is this. Two hydrogens combine to give you a helium nucleus. So this reaction also gives you lots of energy, but still this is an endothermic reaction. But the requirement for this reaction is very high, because in this reaction, you have to give lots of energy, and pressure, high pressure is required in this, which is not feasible by any chance on this earth, right? So this reaction still releases lots of energy, but it's a cold endothermic reaction. Now conditions, as I told you, very high pressure, very high temperature is required, which is not feasible on this earth, right? This practically is not possible here on this earth. Now, important few things. Once you understand with that, now there are few more. One topic which is left here is basically the atomic reactor. Now, what exactly is atomic reactor? First of all, let me show you the picture of that. Then we are in a better condition to understand what is atomic reactor and what does it actually work. Now, atomic reactor is an equipment which is used to perform nuclear fission reaction. Now, what exactly it is? Check it out. If you see that nuclear reactor, what you have seen here, I can show you. First of all, you can see these rods. These are called control rods, these ones. That one is a control rod. And these ones are called as fuel rod. When you say fuel rod means you're talking about uranium. So this is uranium. And this is graphite moderator, this one. This is pressure vessel. Now, each and everything has a function in it. First of all, what is meant by fuel rods? Now, first of all, there are two, three things which are very, very important. Fuel rod is the actual fuel through which the reaction is being performed. Now, there are two, three things which you need to take care of. First thing is number of free neutrons in the reaction and energy of the free neutron. So main components are control rods and moderators. Control rod, as the name suggests, because if this reaction is uncontrollable, then there can be a very big explosion or it will be very, very dangerous. So for what that reaction, these control rods are used, and they are just a rod that are used to absorb the neutron which are released during the reaction. Because if neutrons are keep on releasing and you cannot control it, then this reaction can be out of control. Moderator is a graphite one, which I've just shown you, is used to actually reduce the speed of the electrons which are just came in. So control rod, when you push it downward, it will absorb the neutrons which are just released. And graphite moderator is used to reduce down the kinetic energy of the electrons and all that. Fuel rods are definitely used to, that is a reaction which is actually through which the reaction is being performed. So what is the control rod purpose? To absorb the neutron. Lowering the rod further decrease the rate of fission as more neutrons are absorbed. Raising the rod increase the rate of fission as fewer neutrons are being absorbed. And what is the purpose of moderator? To slow down the neutron. As I just told you, moderator is a matter that surrounds the fuel rod and control the rods inside the reactor, core reactor. Now you have a shielding on. So the neutrons are called thermal neutrons. This ensures neutron can react efficiently with the uranium fuel. Next is a shielding in the nuclear reactor. Now shielding is there to save the radiation that are coming out from the people who are working. So shielding is also there so that everyone who's just there working will be saved. And that is what we are end up with the our content of all that fission, fusion, and nuclear reactor. I hope you like that. In the next class, we will continue with the electricity. So that will be our lecture number 26. So hope to see you soon in the next lecture. If you have any queries, if you want to join further, like for the past papers and everything, you can join Mixit. You can join me through Mixit. And hope to see you with myself. Thank you for watching. Bye.